Hello and good evening. So today the weather is also very nice. It's cool, calm. It's a bit cold here in Bangalore. I mean, this is the first time, it's so cold in Bangalore. I have been staying in Bangalore for quite a few years now, but this is a weird experience for the first time. But still, the weather is fine enough to do one more video and welcome to Edutechy, and we are sharing these videos with you so that I know there are a lot of people who has a lot of problems in data structures and algorithms. I also used to have it, so I don't want other people to suffer, and I know that there are a lot of videos already available, but in a lot of videos, if you see that you will face a lot of difficulties in understanding, so I'm trying to make it as simple as possible for all of you. So let's get going. So let me share my screen, and today's problem, the problem that we are going to do is longest common prefix. So what is this problem all about? So let us take a string array. So let's consider that there are certain elements in this string array. So let's consider the first element to be flower. Okay. What is the next element? Let's consider the next element to be flow. And finally, we'll consider the final element to be fly. All right, beautiful. So what is the longest common prefix here? The longest common prefix in this particular string array is going to be FL, because if you see, prefix means beginning, it starts from the beginning. Suffix means it starts at, it is at the end, it is pointing at the end. So longest common prefix is FL, because FL is something which is common to all three elements of this particular array. Right, the problem statement is clear. And if we do not have any prefix, if we do not have any longest common prefix, then we are going to return an empty string. We are going to return an empty string. So that's the problem. I hope the problem statement is clear to everybody. I will not waste much time going over and over this problem statement. It's a pretty straightforward and simple problem to understand, right? Now, how do we solve this problem? So let's consider that our longest common prefix is the first word in this particular string array, the first word. So let's consider that the longest common prefix is flower. All right. Okay. So now there's a method. We are going to use a function which is called the index of. So index of function is something which is available in most of the programming languages because it is a very straightforward function, right? For example, if I ask you what is the index of f in flower, that is going to be 0. What is the index of L in flower? That is going to be 1, right? So similarly, we have already considered our longest common prefix to be the first word in this particular array. So of course, we start iterating from the next elements of the array, right? So let's consider that our array runs from 1 to, so let's consider I, which runs from 1 to end of the array, right? So 1 till E O A. E O means end of array, right? So now we will try to understand what is the index of this longest common prefix in the first iteration. So in the first iteration, of course, the word that we are going to encounter is flow. So what will be the index of flower in flow? Of course, is it 0 or not? That is going to be our check. So index of flower in flow is of course not 0, right? So what do? We chop off R from here, right? Again, we check. What is the index of FLOWE in flow? Index of FLOWE in flow is also not 0. So again, we chop off E. Now we have this word flow. So our longest common prefix now becomes flow. So what is the index of flow in flow? This is 0. So what do? We again move our iteration to the next index. So now we are comparing the index of the current longest common prefix with the new array element, which is fly now. So what is the index of flow in fly? So index of this longest common prefix flow in fly, of course, it's not equal to 0. What we are going to do now? We'll chop off W from here. Again, we are left with FLO. That's our current longest common prefix. So again, we check. What is the index of FLO in fly? That is also not equal to 0. So we chop off O. Now we are remained with FL. What is the index of FL in fly? If you consider FL as one entity, the index of FL in fly is 0. So we stop here and this is our answer. This is our answer, right? So it's a pretty straightforward problem. And when we are chopping it off, that means we are just taking the substring of the existing longest common prefix. That's it, right? Okay. So let's try to code this solution up. Let's try to code this solution up. So what did we do? In the first case, we considered that our longest common prefix, say our prefix, is our first word. So this is str0, right? Now what do? We now start running our loop from the first index of the array till the length of the array, right? It has to be less than the length because we start from 0, of course. And since we have already taken the first element of the array as the longest common prefix, we start iterating from the next element onwards, right? Now what are we doing? So while we are saying that strsi dot index of this prefix is not equal to 0, that is when what we are doing, we are just chopping one character off until it is 0, right? So prefix is equals to, and I told you that to chop off character, we have to take the substring, right? So prefix dot substring, and from where, what should be our first index? The first index should be, of course, 0. And what should be the last index? The last index should be prefix dot length -1. Now, why did we do -1? That's interesting to understand. So we all know how substring works, right? So let's say we have this longest common prefix flower and we want to chop off R. So what will be our index? When we take the substring, the beginning index is always this index. It starts from 0, right? But when we take the ending index in substring in Java, when you do substring, it actually, if we consider the beginning index to be B, then it takes in B. But when we give the ending index, it actually considers ending -1. So in this case, if I take the length, what is the length of this particular string flower? 1, 2, 3, 4, 5, 6, right? But since it starts from 0, so this R will point at index 5, right? So we do longest common prefix dot length. Length will give me 6. -1 when I do, my ending index will be 5. Now, as I told you, that when we take substring, it actually takes in from B to E -1, so it will take from 0 to 4. I hope I'm pretty much clear why I took the ending index as prefix dot length -1, right? And then we are almost done, and this loop is going to iterate over the entire rest of the array, and then we are going to find the longest common prefix. I already showed you how it works, right? And we just return prefix. Fantastic. So let's run this code and see if it works. Fantastic. So we see that the longest common prefix is FL. I'll just increase the font size a bit. Let me see if I can do that. Yeah, so this is the code that we are currently doing. This is the code. So again, just I'll reiterate the code. What did we do? We took the first word as our longest common prefix flower. Then what we are checking, that we are starting our loop from the first index till the end of the array. So we start from flow till fly. And then for like we try to check that, okay, strsi dot index of prefix until that is not equal to 0. So what is strs? What is the longest common prefix? So we are essentially checking here the index of the longest common prefix in this element flow. Is it 0 or not? So what is the index? What is the index of flower in flow? The index of flower in flow is not equal to 0. So we take a substring and we chop one character off. So we chop R off. Again, FLOWE is the current longest common prefix. Again, we check that whether FLOWE is, when we take the index of FLOWE in flow, that is also not equal to 0. So we chop E off. Now we are left with flow. So the index of flow in flow is of course 0. So we move on to the next element in this particular string array, which is fly. So now what is the index of flow in fly? Because that's our current longest common prefix. So index of flow in fly is again not equal to 0. We chop W off. We are left with FLO. What is the index of FLO in fly? Again, it is not equal to 0. We chop O off. So we are remained with FL. And what is the index of FL in fly? Index of FL in fly is 0. So we move out and our array iteration also ends, and therefore we'll return longest common prefix, right? So that is how we do it. Now, what is the time complexity of this particular code? That's a very interesting question, right? So the time complexity of this outer loop is going to be O of n. Of course, O of n, right? Because it's directly proportional to the length of this particular array. Now, let us try to look at this inner particular loop. What are we doing? We are doing strs dot index of prefix not equal to 0. That means that the worst case scenario is that we have to go through the entire length of this longest common prefix. That means we have to shrink this entire length of longest common prefix. So if we consider the entire length of the longest common prefix to be m, so let us write it down. The outer loop runs in O of n, right? And since we are using index of, so index of prefix, stri dot index of prefix not equal to 0, the worst case scenario, this index of method will take O of n times to run. Will take O of m times to run, where m is the length of this particular string, because we are doing a string comparison at the end of the day. And then every time this condition is true, what we are doing, we are trying to take a substring. And substring, in order to do the substring, if you see the internal working of substring takes another O of m times. So I can say that substring will again take O of m times. So the total time complexity of this particular solution, total time complexity of this particular solution is going to be m O of n into m square. That will be O of m into m square. So that's not a very good time complexity. So is there scope to reduce the time complexity? Will be my next question. But before that, we are going to see what the space complexity is going to look like. So what would be the space complexity here? Of course, we are taking substring every time. And since we already know that strings are immutable, so every time you take a substring, you are actually creating a new string object in the heap memory. Once you're chopping that character off, it's a new string. So you are creating a new string object in the heap memory. So your your space complexity is going to be O of n, because they are going to be stored in different memory locations in the heap memory, because strings are immutable, right? So the space complexity here is going to be O of m, as strings are immutable, right? So now again, coming back to the question, how can we improve this solution? Because of course, m square is not a very good solution, right? So m square is not a very good solution. So what can we do to improve this solution? Let's come back to this particular thing again, right? So let me undo this. So if you see one thing over here, right? So if I go back to this problem, see, with a normal naked eye, when I look at this particular string array, what do I observe here? What do I observe, guys? That I can simply do a check, right? I can consider this first element to be my longest common prefix, and then from the next element onwards, I can iterate. I can run a loop here, and then I can check. I can simply check whether this character is equal to this character. If this character is equal to this character, I can simply take the substring of this character. I can simply take let's say I'll not take a substring. Let's say I have a iterator which is j, right? I put j to 0, right? So what do? I check whether this character and this character is equal. So if it is equal, I just increment j by 1. Again, I move here, I check, okay, this character and this character is equal. So I increment j by 2, right? So my j now becomes 2. And then again, when I check, okay, if this character O and O is equal, okay, my j becomes 3 in this case, right? My j becomes 3 in this case. So what do? Again, w and w, okay, again this is equal. So my j becomes 4, and afterwards it's not equal, right? So afterwards it's not equal. So in this case, what do? My j becomes 4. So now I take a substring from 0 to 4 minus 1. Why 4 minus 1? Because again, the longest common prefix, it starts with 0. So 0, 1, 2, 3, 4. 4 will point to character E, but I need to take this portion, right? So in the first iteration, my longest common prefix will become FLOW. But the only change here is that I am not taking substring every time. I'm just iterating J, and finally when my loop breaks, finally when the characters are not equal, that is when I break out of the loop and I take a substring. So the substring that I'm taking, I'm not taking it every time, unlike the last case, right? Again I put my J back to 0 and I move to the next string in this particular string array, which is fly. Reset my J counter to 0. Now what happens? Now my longest common prefix is flow, right? Again, see, F and F matches, okay? So my J becomes 1, L and L matches, okay, fantastic. My J becomes 2. Now O and Y doesn't match. So again, I take the substring from 0 to 2 minus 1. So 0 to 0, 1, 2. So if I take, if I take 0 to 0 comma j, then it will give me, sorry, it was my bad. It was not j minus 1, because as I told you, it will be n minus 1. When I take the substring, the last character, the last limit minus 1 is what Java takes. It starts from the beginning index, exactly from the beginning index, but whatever you put at the ending index, it is ending in index minus 1. So I take the substring from 0 to j. So in this case, my j is 2. So the substring that I'll be taking is 0, comma 2, which will give me FL. So in this case, as I told you that I'm not repeatedly taking the substring, so I actually avoid that time complexity, extra time complexity O of M, right? So let's code the solution up and see how can we just change this particular code, right? So what I was telling, yeah, I'll take my longest common prefix to be the first element of this particular array, and then I run my loop starting from 1 till the end of the array, which is completely fine. Now I was taking a counter, sorry, I was taking a counter j equals to 0, right? And now I'm going to make some small changes over here. So what am I actually doing? I'm actually trying to see that whether my strs I dot length, so str, whether my j counter is less than strs I dot length. Of course, it has to be less than the length of this particular string. For example, what is strs I dot length? It is flow, right? So j counter has to be less than strs I dot length. Otherwise, it's not possible, right? Otherwise, it's going to be overflow. See, you see, if I have to compare E with the next character, there is no next character, right? So we cannot compare, right? We cannot compare. That's going to give us an exception. So that is why I'm putting this check, that while j is less than strs I dot length, and also there might be the other way around, that the length of longest common prefix is actually less than the length of the next element in this array, right? So I also have to put another check, that and j is less than prefix dot length, right? J is less than prefix dot length. And what else I'm going to see now when I do this checks? Now I'm actually checking that whether the character of both, so pardon my mistake, yes. So now what am I going to check is that whether strsi dot character at this index is equal to my prefix dot character at this index. Until this condition is true, until the characters are equal, I'll keep on increasing. What am I going to do? I'm not going to take substring every time, unlike the other case here, right? I'm going to do j plus plus. I will increase my counter, and once I'm out of this loop, here is where I'm going to take my substring. So my substring is going to be prefix dot substring, and this time it's going to start with 0 till j, as I already said, because the ending limit, it's always ending minus 1, as I already told you, right? Now if I return the prefix, now in this case, if you see, let me run this particular thing and show you if we get the same result. All right, fantastic. We get the same result. Now, how do we improve? Because we are not taking this substring inside this while loop. So we are actually saving the time here where we were doing substring. We were taking O of M time to do the substring every time. Here we are taking O of 1 time because we are just calculating it once or maybe twice or thrice. But it is not directly proportional to the length, right? So in this case, what happens? The time complexity reduces. In this case, in the improved solution, let me write the improved solution and the improved solution, my time complexity becomes O of n for the outer loop and then another O of m. That's it. Another O of m. Why another O of m? Why another O of m? Because I'm running this while loop, of course, to increase the counter, right? So it's just O of n cross m, which is equal to O of n cross m. That's it. That's it. And also I improve my space complexity, guys, because unlike in the previous case, every time I was running the while loop, I was taking a substring and that was creating a new string in my heap memory, right? Because strings are immutable. I was not using a string builder or a string buffer, right? I was using a string which is immutable, and every time a new string was getting created. So in this case, what will happen? I will have an improvement over my space complexity because I'm not creating substrings every time. So my space complexity will also be a constant space complexity, order of 1. Right? I hope you enjoyed this problem and the different solutions that we did in this problem. All the best, guys. If you like my video, please like, comment, and subscribe our channel, and that will honestly encourage me to come up with many more videos like this, where I'm going to try to simplify the solution as much as I can for all of you. And all the best for your interviews, guys. I'm pretty sure that you're going to rock it. Also, I'm going to add in the description our website address. The first version of our website Edutechy went live a few days ago. Our contact number is also mentioned in that website. Our email address is also mentioned in our website. Please feel free to reach out to us if you need to talk to us and if you need our help. And it's not that you always have to do courses from us. You can always also talk to us just for guidance. That is also completely fine. And please do suggest if you have any better solutions than the solutions that I provided. I will be more than happy to learn from you as well. Thank you so much. With this, I'll stop sharing my screen and I am also going to stop the recording.